Hi, welcome to my video on prime factorization. Prime factorization of a natural number is to factor a number such that each factor is prime. We call a prime number is a number with only two different factors, one and itself. Prime numbers are 2, 3, 5, 4 is not prime because it has more than two factors. 6 is not, 7 is, 8 is not, 9 and 10 are not, 11 is prime, 12 is not, 13 is prime, 14 no, 15 no, 16 no, 17 yes, 18 no, 19, and we can keep on going. Remember, prime number has only two factors, one in itself. Note, 1 is not a prime number since it has only one factor of 1. 1 cannot be used in the prime factorization of a number. The prime factorization has to be in ascending order, like 2, 3, and 7 multiplied, or 3 and 5 with a power of 2, or exponent of 2, 3 and 5 in order. Or you could have a 2, a 7, and 11. Ascending order, smallest factors to the largest factor. In exponential form, better write in form. And exponential means exponent, so 2 and 3 are in order with a power of 2. 3 and 5 are in ascending order with powers of 3 and 2. You have to put them in order first and then the exponential powers or exponents. 2, 3, 5, powers of 2, 4, and 2. Let's change to prime factorization. So if we look at A, we see a 2. I see a 3 as a factor. I see 5 as a factor. The 2 has only a 1. The 3 has 1, 2. There's 2 3s. And there's only 1 5. B, I see a 2. And I see a 5. And that's all. But there's 3 2s, so that's 2 cubed. And there's 2 5s, so 5 squared. Remember, when you're multiplying, you add the exponents. And in C, I see a 2, and I see a 3 factor, and I see a 7 in that order. With the 2s, I have 2 2s, so it's 2 squared. 3s, I have 2 3s, so it's 3 squared, and only 1 7. Do some practice, pause, fill these out, and then come back, play it. I see a 2, a 3, and a 7. And there's 1 2, 1 3, but there's 2 7s. In the second one, I see a 2, and I see a 3, and I see a 5. And 2s, there are 2 of them, squared. 3, there are 2 of them, so it's a square, and 1 5. Number 3, I see only a 2, and there's 1 2 3 4, so that's 2 to the 4th. Number 4, I see a 2, and a 3, and a 5, and 11 in that order, and there's only 1 2, 1 3, 2 5, 5 squared, and 1 11. Number 5, I see a 2, and a 3, and a 5, and a 7. And I see only 1 2, 2 3s, 3 squared. I see 3 5s, so it's 5 cubed. And I see only 1 7. Let's practice in writing down the prime factorization. Now, let's go through and do the prime factorization. Divisibility rules in prime numbers can be used to find the prime factors. There are 3 methods to find a prime factorization number. I call it the normal method. Normal would be to take 24 and write it down as 6 times 4, or 4 times 6. And then you break 6 up into 2 times 3, and 4 is 2 times 2. And note, that's a 2 and a 3 are the factors, but there's 3 2s and only 1 3. We could do 24 another way, but it's the same thing. 24 could be, say, 3 times 8. 3 is okay because it's prime. 8 is 2 times 4. And the 4 is 2 times 2. So you keep breaking it down. Again, you got a 2 and a 3 as a factor, and there's 3 2s and 1 3. So you get, no matter how you do it, 6 times 4, 3 times 8, or 2 times 12, you'll still end up with 2 cubed times 3. 90 is a 9 times 10. The 9 is 3 times 3. The 10 is 2 times 5. Notice 3 and 2 and 5 are primes. 9 and 10 are not. So I have a 2 and a factor of 3 and a factor of 5. 1 2, 2 3s, so it's 3 squared and 1 5. That's normal. There's another method called the ladder method. And we'll do the ladder method in another topic of what we call least common multiples. But right now, to do the ladder method, we start with the smallest prime number 2. Notice this is even because it ends in a 4. So we take the 2, put it here, and we do a little L shape. 2 into 24 goes 12. Again, notice that it's even. So we go with another 2. So 2 into 12 goes 6. Notice that 6 is even, so we go with another 2. So 2 into 6 is 3. Notice 3 is prime, so we can stop. Once we get down to the last number here, which is prime, then that ends it. So we have a 2 and a 3, but we have 1, 2, 3 2s and 1 3. So this is the ladder method, working it down. So it's very similar to the normal method, only it's just, but notice in this method, when you start with a 2, and then you go to a 3, and then you go to a 5, then you go to a 7. When you can't do a 2, when it's not even, you go to a 3. When you can't do a 3, with the digits adding up to be a multiple of 3, you go to a 5. You keep going till you get to the end, and the last one is a prime number. 90 is even, so we divide by 2. So we get 45. 45 is not even, so we try a 3. 45 adds up to 9. 9 is a multiple of 3, so 3 will go into 45. 3 into 4 is once. 3 into 15 is 5. We have a adding up. 1 and 5 adds up to 6. 6 is a multiple of 3, so again we can divide by 3. 3 into 15 goes 5. Notice that 5 is prime, we can't go any lower. So we have a 2, a 3, and a 5 in that order. And we have 1 2, 2 3s, 1 5. Now if you take if you multiply these out, you'll see that you're right, because 2 times 5 is 10, and 9 times 10 is 90, so this is correct. Another method is what we call the factor 3 method. A lot of people do this one. Factor 3, we break it up into like branches. We start with 24, which is, and we go little arrows. 24 could be 3 times 8. 3 is prime, so then we look at the 8. The 8 is 2 times 4. And the 4 is not prime, so the 4 becomes 2 times 2. So again, notice we have a 2 and a 3, but we have 3 2s and 1 3. Same answer each time in the normal, ladder, or factor tree. And the factor 3 for 90, we break it down. We can break it down into primes. We don't have to. We can break it down into, if we want to, 9 times 10. So this is the advantage of the factor tree. We don't need prime numbers right away. And 9 becomes 3 times 3. 10 becomes 2 times 5. 3's, 2's, and 5's are prime, so we have the factors of 2 times 3 times 5. 1, 2, 2 3's, 3 squared, and 1 5. Notice the three answers are the same. So 3 different methods. It's your choice what you want to do. Factor tree, most people will pick. The ladder, keep in mind we'll need to use the later, but the factor tree is what I'll be doing. Find the prime factorizations. Now it's up to you and me, but 6 is 2 times 3. So you can't go any lower, so 2 times 3 is the prime factorization. 8 is made up of 2 times 4. 8 is even, so 2 will go into it. 2 4s makes 8. 4 is 2 times 2. So 8 is a factor of 2, no more, and there's 3 2's. 10 is broken down into 2 and 5, 2 times 5. So the prime factorization of 10 is 2 times 5. 11 can't break down. We can't do prime. 11 is already prime, so it stays. Can't do anything about it. I just put that one in to let you know that. Normally, that doesn't happen because when we do prime factorization, you normally get a multiple of factors. 18 is, most people say is even, so they go 2 times 9. 9 is 3 times 3. So you got a 2, and you have a 3. 1, 2, 2 3's. 1, 2, 2. Again, 3 squared is 9 times 2 is 18. 45, I see a 5, so I see a 5 times 9. 5 is prime, so that's okay. 9 is 3 times 3. Can't go any lower. 5 and 3 are prime, so we have a 3 factor times a 5. But we got 2 3's and a 5. 3 squared is 9 times 5 is 45, right? 48. Again, it's your choice. Many, many numbers make up 48. 2 times 24, 6 times 8 is what, or 2 times, whatever you want. So if you see that 24 is 6 times 8, 6 8 are 48, then it's quicker. 6 is 2 times 3. They're prime. 8 is 2 times 4. And 4 is not prime, so 4 is 2 times 2. So notice 2, 3, 2, 2, 2, they're all prime. So we got a 2 and a 3 as a factor. So we got 1, 2, 3, 4. 4 2's, 4, 2 to the 4th, and 1 3. Notice 2 to the 4th is 16. 2 times 2 times 2 is 8. Times 2 is 16. And 16 times 3 is 48. You could do other combinations. Again, whatever you want. 3 times 16. But 50 is 5 and a 10. And when you multiply, 5 is prime, 10 is 2 times 5. And they're all primes, so we have a 2 times a 5 as the factors. 1, 2, 2 5's. 25 is 5 squared times 2. So there's the prime factorization. 68 could be 2 times 34. Because it's even. 34 is even, so we go 2 times what number? 2 times 17 is 34. And if you can't find it awkward, take 34 and divide it by 2 and you'll get the 17 with a calculator, but try to stay away from the calculator if you can. Factors are 2 and 17, and we have 2 2's, so it's 2 squared. 252, notice is even, big number now. So you still go with the divisibility rules, primes, and things like that. So, but if it's even, keep going with an even number until you break it down, if you want. So go with 2 times what? Well, 252 divided by 2 is 126. Again, 126 is even, so go with a 2 again. So 2 times 2 into 12 is 6, 2 and a 6 is 3. Now we got a 63. And notice that the digits adds up to be a 9, so I can have a multiple of 9, factor of 9, or I could have a factor of 3. Makes no difference. It's your choice. So if you go 9, 7 nines is 63. But if you go 3 into 6 is 2, 3 into 3 is 1. You have a 21. 21 is not prime. 21 is made up, again, 3 and 1 adds up to 3, a multiple of 3. So that's 3 times 7. And we have a 2, a 3, and a 7 as different factors in order. Then there are two 2's, 2 squared, 2 3's, 3 squared, and we have a 1 7. So this is what we got working up the factor tree. I like the factor tree most of the time. You can use the ladder if you want, or you can use normal. I find this is quicker. 405 is broken down. I see a 5, so I write down 5 times what? Well, 5 into 405 is 81. 81, you could right away. Most people see 81 as adding up the digits, adds up to 9, so it's divisible by 9. So 81 is 9 times 9. And the 9 breaks down into 3 times 3. And that 9 is 3 times 3. So we have 3's and 5 as factors. How many 3's? 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4. 4 3's, 1, 5. Now, we have more. But this time, what you can do is you can pause and work out these yourself to see if you get what I'm going to get. Here we go. 9 is 3 times 3. And we know 9 to be 3 squared. There's only 1 3. 13 is prime, so we can't do it. It's already prime. 15 is 3 times 5. So the prime factorization is 3 times 5. Notice I already have them in order. 16, you could have 16 as 16 is even, so you can go with a 2, or you can go with 4 times 4. And the 4 is broken down into 2 times 2. And this 4 is 2 times 2. Only 1 2. 2 is the only factor, and there's 4 of them, so it's 2 to the 4th. 27 is, adds up to be a multiple of 9, or a multiple of 3, your choice. So you can go 9 times 3, or 3 times 9. 9 is 3 times 3. And we have one factor of 3, and there's 1, 2, 3 of them. So 3 cubed is 27. 30 is, again, 10 times 3, or 3 times 10. 10, reason is 10 times 3, 1 is if it ends in a 0, 10 is a factor, so it's 10 times 3. If the digits adds up to be a multiple of 3, 3 is a factor. So either way, I'll get 3 and 10, or 10 and 3. 10 is 2 times 5. And if you notice, I have a 2, and I have a 3, and I have a 5, multiply together, and there's only one of each. 44 is your choice. You can go with 2 times 22. I see a 4 because the repeat, so I'll go with a 4 because 4 is repeating. So 4 into 4 goes once, 4 into that 4 goes once. So 4 times 11 is 44. And 4 is not prime, 4 is 2 times 2. 11 is prime. So I have a 2 times 11. There's 2 2's, so it's 2 squared times 11. 75 ends in 5. So we got a 5, ends in 5, and multiply. 5 into 75 goes 15. 5 is prime, 15 is 3 times 5. And we have a 3 and a 5. So we have 1 3 and 2 5's. We could have went with 3 and 25 from the scratch and then break 25 on the 5 squared. So either way, it's lots of options. 98 is, can't get it. So I think it was even, so I'll go with a 2. 2 divided into 98 is 49. Now you wouldn't have picked up 49 right away, but you would have picked up as even. And 49 is It's not even, not 2. Can't divide by 2, can't divide by 3, can't divide by 5. And we try a 7, and we discover that 49, well, yeah, 49 is 7 squared. So we have a 2 and a 7, 1 2, and 2 7s. 2 times 7 squared is the factorization. 99, I see a 9. 9 is repeating, so that's 9 times 11. And a 9 breaks down into 3 times 3. All factors are prime, 3 and 11 in that order, and it's 3 squared times 11. 150. Could be. I see a 10 because it ends in a 0, so I'll go with 10 times 15. A 10 is a 2 times 5, and a 15 is a 3 times 5. So 2, 5, 3, 5, they're all primes. So I got a 2 and a 3 and a 5, 1, 2, 1, 3, and 2 5s. So if you took a calculator and worked that out, you get 150. And the last one is 231, again, an awkward number. Is it even? No, we can't do 2. The digits add up to 2 plus 3 is 5, plus 1 is 6. 6 is a multiple of 3, so that means 3 is a factor. 3 is a factor. So 3 into 2, 3, 1. Let's see. Sometimes, if you don't have a calculator, 3 into 2 can't go. 3 into 23 goes 7. 3 7s are 21. And we get subtract, get a 2, bring down your 1. 3 into 21 goes 7. So we have a 77. I used an arrowhead here just then. I didn't have to, but just use a straight line, straight segment. And 77 is, 7 is repeating, so 7 into 77 gives you 11. So I have a 3 times a 7 times 11, and non-repeating. That's it for prime factorization. Hope you enjoyed the video. If you did, click on my buttons, the buttons of like, subscribe, and notification bell to receive future videos that I'm going to do. And if you want, write a comment. Plus, visit my website at www.mathfullyexplained.com. You'll find information about me, my degrees, and teaching experience, and my videos telling you the strategies I'm going to use in the teaching of my videos. And my YouTube channel content will be on that section. We'll have the topics I'm going to have, the number of videos on each topic, and the topics completed will be in black font, and the topics to be completed will be in red font. Thank you very much. Bye-bye.